Well, hi everyone, and greetings from Shamrock Banks Observatory in northern Michigan. I'm Bob the Science Guy. Last night we had good weather, so the observatory was tasked with taking pictures of constellations for my Learn the Sky series. However, when I was checking the clouds, I saw that we had a very fortuitous passage of the ISS just before 7 o'clock at night. So I decided to go ahead and do a live stream of that and try and capture the ISS using both the telescope and the radio. So let's cue up the music and see how I did. Now I took a moment after a long night of observing and took a picture of my rig so that you'd see how I did this. Now as you can see, I've got the Celestron CGX-L mount, which is my main observatory mount. I'm running it with the Alienware laptop, and on the mount I have two imaging instruments. The first one is the Eon 110 refractor. That's a 110 millimeter refractor, it's a triplet, and on top I have the Canon SL1 Rebel. Now when I'm taking pictures of large objects like the constellations, I need a very wide field, so my primary camera on this particular shoot is going to be the Canon DSLR with a 35 millimeter lens on it. The reason it's mounted on the telescope is that with that short focal length there are so many stars it's very difficult for the computer to do plate solving. So in essence, I'm using the big telescope as a guide scope and taking the images with the camera. Now I'm going to show the video from last night. This has been slightly edited, although I'll have the full raw 9-minute video available as an unlisted video. I'll put a link to it in the description. But here's my setup. Obviously I'm down on the lower left. In the upper right is my software-defined radio, and it's tuned to 437.8 megahertz, which is the repeater frequency on the ISS. And in the background, I have Stellarium showing the ISS current location and its orbital path. The yellow circle with the crosshairs in it is the location that my telescope is pointing. As we're waiting to see some radioactivity up in the upper right corner there. So what we're going to do is we're going to drop this down to about half a second. I've got to manually track this. All right, now, if you look right here, the ISS should be coming into view very shortly. So we're going to go ahead and we're going to switch over to the camera. We're going to kind of switch back and forth. I think that's it right there in the center. It's right there. Right there. That's it right there. See it?
Okay. Yes.
Now, what's going on with the radio? Anything? So we definitely have the ISS. So we're getting some right over here to the side. Right there. And that's 437.809. You see how it's starting to shift already? Okay, so what I've done so far is I've set the entire telescope up. I've got it matched to the sky. I've done some plate solving. So the telescope, I know where it's pointing. And I use the telescope to point the camera to where the ISS would appear over my horizon. Now, obviously, as you can see, that's kind of a bad location for me. I have trees that extend up to almost 30 degrees above the horizon towards the west, plus my house is there, etc. But I did manage to pick out the ISS through the trees. Now, the other thing that we're looking for on the software-defined radio is we're looking for the Doppler shift of the repeater on the ISS. So the ISS is transmitting on 437.8 megahertz. What happens is people call up to the ISS on 148.5, and then it relays it from the ISS back down to the ground on 437.8. Now in these first shots, the ISS is over Lake Michigan or maybe even Wisconsin, and it's coming at me at 7 kilometers a second. As a result, the Doppler shift of that radio frequency will move the radio frequency that I'm hearing from 0.8 up to about 0.81. As it passes me in its orbit, the frequency that I receive from the ISS will be the broadcast frequency. And then as it starts moving away from me towards the southeast, and that'll drop the frequency down to about 437.79. And you'll very clearly be able to see that shift if you look at the top graph on that little screen. Let's go ahead and have a look. I want to reacquire the ISS. So we're going to go right here. Whoops, there we go. All right, let's get over here to the video. There's the ISS right there. Right there. So it's moving kind of fast.
Yeah, I can see the shift.
Station passage now. Now, just so you see what we're looking at, if you look at that blue graph on the top row towards the left where it says FM, you see that little green line that's kind of snaking from just to the right of the M on the FM, and then it's kind of moving off to the left? That's the Doppler shift. And that center line is the frequency that the station is broadcasting on. And as you can see, when it crosses that line, that's when I'm getting station passage here at Shamrock Banks. As it's to the right of the line, it's coming towards me, station passage, and then as it moves to the left of the line, it's moving away. Now, this is the first time that I've been able to simultaneously image the ISS passing my location and get the radio on it as well. So we're going to see a couple more images and then I'll finish this up. Yeah, we're definitely picking it up. But this thing here is going to start hauling. I don't even know if the mount's going to be able to keep up with it. Yeah, this is a good one because we're going to clearly be able to see the shift. You can definitely see the Doppler shift in the top graph there.
Yes.
And there it goes right by. Now we'll get back over here. We'll look at it again. It just passed us. Now right about here, it's going to blink out. All right, so here is current position of the ISS. And it has just left the coast right there. And we have lost radio contact with it. Now, normally, due to the curvature of the Earth and the height of the ISS orbit, about 400 kilometers, I can normally pick it up around 2,200 kilometers away. Now, I lost it a little bit earlier at about 12 or 1,400 kilometers because there's a mountain range between me and where it went over the horizon, the Appalachian Mountains. So as a result, I wasn't able to get it all the way down to the horizon because the mountains were blocking me. There are houses out in that general direction, etc. But we still managed to track it all the way out to the coast of North Carolina. Now, when I do this again, I'm going to try and do it with continuous tracking rather than this leapfrog. I didn't get the continuous tracking working in time to get it tonight, so I had to kind of jump ahead of it and then let the ISS go through the field of view. Now, when you do continuous tracking, you can use much shorter exposures. It's no longer just a dot of light. You might actually even be able to get some details, especially if I use some of the larger telescopes. The 10-inch Meade is going to be ready for action here pretty quick. I can track the ISS with this particular mount, and we may be able to get some high-definition views of the ISS sometime in the near future. So until then, this is Bob the Science Guy signing out from Shamrock Banks Observatory in northern Michigan. Take care and clear skies.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. sky.